Thank you, Anit. So I will invite two additional people here with me, much smarter than me. One is Dr. Mart Noorma, who already introduced himself in a way that he's the director of NATO CCDCOE, NATO Cooperative Cyber Defense Center of Excellence. I've been saying this for 8 years, but still I get it wrong. And also he has been head of innovation and digital transformation in many organizations, and he was chief science director in Milrem. He also worked with the standards in NIST, and is a key person who helped to put Estonia's first student satellite test cube into space. So, Mart, welcome.
Thank you.
And then we have another great mind, Dan Bogdanov, who already also introduced himself, but Dan is the mind behind the share mind. So it's his baby, which started when he was collecting genome data, and basically it allows to do a lot of smart stuff without actually knowing the data which we don't want to reveal, and it helps to get our data protection on another level. And it's been used in several Estonian government systems, and also he has worked with Horizon projects and DARPA, which is the Defense Research Agency for the United States. So please, Dan. So the way we're going to do it is I'm going to be the kind of the average commander of the military, who kind of wants to know that how to wage war in a good way, because what we have witnessed over the last months is that technological superiority in warfare has changed a lot of things that we've known so far. So when we used to know that there has to be 3 attackers for 1 defender, so it would be effective, this has changed. So basically what we have seen is Ukraine has done a great job with having all this intelligence from space, having the ability to kind of command and control not only the troops, but trust me, HIMARS won't fly if you only have cable connections. So you need those assets. So GPS, all those things have enabled them to kind of wage war in a new way, and kind of make obvious how this technological superiority looks like. So, military commander, the first thing he wants to know is basically what assets he has and kind of how it works. So, this time we will not start from the ground. Ground base is something that we might cover during this, but let's go back up in the space, and maybe one of you starts explaining how this stuff works.
Mart, you know how space works better than me.
Yeah, that's a very good direction how to proceed. But maybe I start from very different angle on that. And as I represent NATO Cooperative Cyber Defense Center of Excellence, then our aim is to support our 38 nations in their cyber operation capability development. And how it relates to space, well, as you might know, cyber domain, which is new addition to traditional domains like air, land, sea, and space, has one particular property, which means that its environment is completely human-made as an environment for operations. So quite obviously, all space assets are very much linked to cyber capabilities that will have effect on very earthly systems. And what kind of capabilities we are looking at from cyber point of view at our center, where we see our 38 nations have most interest and need for capability development, then, and that's generally not specific to space. So first of all, it's just general capability to carry out cyber operations, either defensive, offensive, or so on, but cooperate on this development. So we talk about common framework of cyber operation capability. that's kind of similar to just building your own satellites, building your own missiles. But the next capability that is important for cyber is capability to have joint operations. And joint means different domains acting together efficiently. So here we can ask, how well our space community is ready to cooperate with other domains to provide effects that would be based on contribution from all domains and which have most impact on the battlefield. So from there, the next question is combined operations, which means multinational operations, several nations working together. And space traditionally has been something where cooperation is very wide, and it has survived even Cold War in a kind of peaceful way. So here again, kind of general question is, if we talk about space technology development, our capability and cyber secure space assets, then one way or another, question of international cooperation will pop up. And then it will be led to standardization, legislation, and joint exercises, so on, to actually being able to cooperate. The next two and the last two capabilities here are also very relevant to space as well. They are public-private cooperation. That means how armed forces can cooperate with industry efficiently. And there is a huge difference now in cyber as compared to other domains, or kind of old school warfighting, where typically assets were developed and manufactured by industry, and then handed over under the control of armed forces, that means the governments. So in cyber, most of the cyber environment, most of the assets are actually not only developed, but also owned and controlled by industry. So that brings up a lot of questions about governance. And again, within our friendly community of nations and industry, we can solve these questions about procurements and authority and so on. But as we know, it always takes time. But if we have already a conflict ongoing, we are under attack, we don't have time to kind of play through procurement procedures and start thinking how we can legally, correctly operate. It has to be practiced, it has to be trained, prepared way before. So now is the time. And well, I was talking about private now, so about civilian military cooperation, which is now this last capability. That's a question about dual use, about joint operation of civilian assets or military assets. And again, it's very common or similar to between space domain and cyber domains that a lot of assets have capability to be beneficial, useful, both in military and civilian area. So I strongly believe we need to find solutions there to maximize benefit for our nations, value for our nations from the investments into space and cyber technologies. So that was my brief answer to your question, which didn't answer to your question at all.
To the point.
So I'm going to be a bit shorter. Yes, basically what he said, but in addition, a lot of the things that have been built in civilian space, all the cryptography, a lot of the cybersecurity stuff, that's also not going to work in a military conflict, no question. Because some of the things that we've built in Estonia, like let's take internet voting, that usually is very divisive in any setting. The amount of security engineering and vulnerability analysis we had to put into that, I think that's pretty military grade. So some of the things we've done in civilian settings, the methodologies, the ways how we learn to secure these systems, I think they'll transition just nicely into the military domain, into the space domain. The governance issue is obviously a problem because, well, security people like to joke around that the cloud, it's just somebody else's computer. It's not a very helpful abstraction. It doesn't foster collaboration, but still some of the ideas that have been developed for civilian use can again be transitioned. Yes, indeed, DARPA was mentioned, and comes to mind a program a few years ago where the goal of the program was to work on privacy technology. So you ask, why would DARPA, which is the Defense Advanced Research Projects Agency, work on privacy technologies? The actual justification was that if services in a society are coherent and trustworthy, and the person or a company knows that their data will not be misused by the other party, then you get better coherence in a society, which is nice. However, one application of the technology coming out of there was also planning joint allied operations in the Pacific theater. How can certain cruisers, let's say flight carriers, exchange just enough data to plan a joint mission, but nothing more? So that was one of the pilots that came out of that program. So again, some of the things that can help hospitals can also help military. The question is exactly governance and ensuring that this particular technology or service will not fail you at your time of need.
Thanks. So for the last 2 days, most of the Western cyber commanders were here, and obviously I kind of picked their brains for this this kind of panel as well. So one of the concerns what they have is basically, and you have, I think, tackled some of it, is basically they have their kind of reconnaissance radars, kind of satellites up there. So basically, and obviously other nations which are having different kind of interest have those as well. So basically there's a lot of stuff there, including debris, and they one concern that they have is that to make sure that they do understand that how to protect their satellites from debris. Other thing is how to protect it from satellites who want to probe them or kind of interfere, like for example communication satellites, to see what's happening there. So basically there are several ways. So kind of how would we approach that?
It's a situational awareness exercise in a way. If you're trying to solve a problem with one eye closed, then it's going to be very harder to solve the problem. And in the satellite in low Earth orbit space, the question is always, there are these commercial providers, all the SATCOM, all these folks who do civilian use, make sure that TV gets shown in remote places and all. But the problem is that there are some satellites in the same orbit which don't want to be known where they are. And then this whole situation awareness exercise becomes very hard. So one trivial idea is obviously everybody who is worried about their satellites not falling down from the sky and not burning in the atmosphere, they just give all their trajectories to the folks who have all the military, the secret ones. That's fine. Then again, if we want to create stronger coalitions, trustworthy collaborations, then again, technologies exist for that. We've been able to prototype a system that can predict satellite collisions in low Earth orbit without anyone learning the trajectories, just you will learn pairwise collision probabilities for that week, for example. That's doable with cryptography. The same technique can technically be used to do other allied, even procurement or defense planning. So again, there is a sort of, there's new technologies coming in, and one of the questions that's why I was addressing Mr. Ruutu here earlier is, how will we adopt those? What will the checklist be? I know in the US you have to go through the NSA to get something sort of validated. In the UK it's GCHQ. In Europe would know where to go in individual member states. But how do we clear something for, defense use across Europe? That's an interesting question for novel cybersecurity technology of any kind.
And continuing on the situational awareness, so the commander needs to know where her assets are, at the same time where the adversary is. So the capability to monitor what's going on in space is extremely important. And to my knowledge, European Commission has fully acknowledged the fact that it's one of those services that should be available in Europe also, even if our good friends are not supporting us with these solutions. They of course are, but we need strategic independence in this direction also. So Europe should be capable to monitor space to the extent that we know where something is.
Mm-hmm.
Okay, I'm starting to kind of come down from this layer. So, for example, I understand it's not like in the movies that you can have real-time picture of every house in the where you want to have. So I think there is a kind of also this dilemma in terms of if we discuss dual use. So we have maybe satellite, which is doing military work, another part of the world, but we need the connectivity to see this picture like in real time. So how do you do you see that it would be okay to have this dual use that military is using the private infrastructure for also intelligence and information gathering purposes, or we should have those two worlds separate?
Well, connectivity is again one of these issues where Europe needs its strategic independence, surely. And how to achieve that has been a big question for quite some time. We can work together with our industrial partners, and that solves our questions quite often. Sometimes, however, it might not be good to be dependent only on a sole system provider if one person can, based on her political views, turn your key off or on. If we have seen some warning examples lately. So working together with governments to have different space communication assets is very important. And again, one solution, for example, let's say low Earth orbit satellite internet network, it's nice. But as in military, you can't do attacks only with drones. You need to have different solutions, artillery, missiles, and so on, because then if you have only drones and the adversary, it's very easy for adversary to be prepared to counterattack drones. So in communication, we definitely need many different solutions, and in all sectors, both this geostationary or the traditional SATCOM and then low Earth orbit. It's definitely what we need is competition between industrial players, and hopefully some of these players will be also from Europe. So industry, please invest, get it working.
Well, fortunately, the internet has been built as a mesh, meaning that you can route to a same location through multiple channels, ideally. Unfortunately, how it's built out is often not so, and currently concerns about undersea communication cables are increasing, unfortunately, so that having more connectivity is certainly a thing. So when we talk about the future of connectivity, there's been some interesting ideas floated in the world about what happens when somebody builds a quantum computer, because that supremacy thing it's going to play out at some point, and I think in some rooms around the world people are thinking that if we get the quantum computer first, we might be able to break certain cryptographic primitives, and thus we'll be able to read everything that the others do. This actually does take me back a lot into 1945, when the British built the Colossus to break the German Lorentz SZ cipher. It's exactly the same. And maybe at some point future, in some stupid conflict, somebody will actually get will get a quantum computer running well enough to break RSA. But well, these days we are already preparing for that. There's post-quantum cryptography and all. But again, that needs that all these new security technologies are somehow accepted and they become interoperable. And that's one of the challenges that we'll have to figure out, because building large interoperability systems in Europe between member states has been a challenge. I agree, we achieved great things during COVID. The vaccination certificates, interoperable, very nice, it worked. But again, these architectures, we need to build more of them and make sure that this actually gets to be mature, it gets to be normal, that we can build European networks of interoperability. So, if anybody has already questions, then just raise your hand, so we might be off topic for you, but hopefully this is still interesting for you. So let's go actual use of the technology. So we have seen that Russia has tried to change the kill chain for Ukrainians. So basically, kill chain is the the speed you can project your military effect to a certain object. So what they have done with at the eve of the attack, they attacked Viasat
to a vendor and basically kind of disabled Ukraine's digital command and control, which is now replaced with Starlink. Obviously really important. At the same time, we see that sea cables in some areas already are breaking themselves. Also pipelines are bubbling, so we see that it is an important domain, and this is kind of a thing that is also important in the cyber community as well, that we already have private sector vendors in the kill chain, in the military kill chain. So how can we protect it better in a way that, or have more control over it as well? Or should we have more control over it? I understand you said that we should have a competition, but the competition is just kind of maybe coming up. What should we do now to kind of in this situation? Easy question.
I would argue that the toolkit exists. Analyzing dependencies and resilience in connected systems is something that computer scientists have figured out quite a while ago. And you can, and this has already been done in the civilian sector, for example, for utilities. You can beautifully draw a graph, a tree about which utilities are powering what's the easiest way to turn off power in that particular building, which connection you need to cut. And that works on various abstraction levels. So in your supply chains, you would have to understand what it is. You would have to analyze what's the single point of failure, where do you only have one provider. If there seems to be just one, then competition sometimes happens to end badly for some of the participants, right? So there might be a monopoly at some point in the end, and that might be a problem. So the idea is that the tools exist, but the analytical capability might not necessarily exist. And the problem becomes when exactly that, again, during time of need, do I have time to do proper procurements? And time has shown us in COVID and elsewhere that in a time of need, there is no time to do proper procurement. So sometimes you get the wrong result, you make yourself too dependent on some single providers, but again, you can prepare, look at what are your weaknesses, do the single point of failure analysis. Which organization are you mostly dependent on for some specific capability? Map it out. There's even some support tools for that. We've done this exercise in Estonia for power grid and some other certain services in a particular R&D project a few years ago. I think there's also a tool that makes that easier for now. So it's just a matter of picking it up and starting to use it.
So today a solution can also be that we are trained to fight without GPS. We still know what compass is, and we have maps on paper. So I hope all our allies also do not to be too helpless without our cyber tools. But the fact is that in the future it's not possible anymore, because all predictions show that manned-unmanned teaming is here to stay. And when we look at product portfolio of significant Estonian industry, then unmanned ground vehicles, for example, will have more and more significant role on the battlefield as wingmen for dismounted infantry or wingmen for next generation European main battle tank. Which could be completely unmanned, but it could also operate in manned-unmanned teaming. And in such a case, the connectivity for these solutions can also be, in significant part, be provided through space technology. And that adds a lot of layers to the skill chain, layers to incapacitate these systems. And we can't replace these units with compass and assault rifle. And I think the only solution I see here is multinational cooperation, European cooperation. Together we are stronger. And one example of this importance of this multinational work is, for example, the same Viasat attack. So if it would have been only Ukraine suffering, maybe nobody would have noticed. But all windmills in wind generators, turbines stopping in Germany is all another story. So if we use similar solutions and work together, then it enables us to better control the situation.
Don wanted to add something.
Yes, I did, but the windmill thing threw me off. That was a.
I can kind of let's go if it comes back to you. Then yeah. So you brought up the GPS.
Yeah, that
favorite topic.
Yeah.
So
it came back to me.
GPS is basically well, many of us can't get home without GPS these days, and unfortunately, in many kind of nations, the military is not capable of going back to paper and pen and the map. So they are really kind of relying on the technology that they already have. So we have the European Galileo, we have, and these are the other nations that are building their own positioning systems probably are willing to give it to us, but on their terms. So what would be the alternative if we still kind of are relying on the technological kind of command and control or C5 systems, and if the GPS is not actually telling you the right coordinates, what are the alternatives?
One thing, obviously, first of all, just like a week or two ago, happened to be in DC at a certain exhibition, and I think I saw at least 5 booths proposing GPS-less navigation as technology for autonomous or something like that. So apparently, industry is on it. But something that has to be considered in the next generation systems is going to be local autonomy. If you lose central communication, then you might still be able to build a unit around certain vehicles, APVs, something like that. Have a combination of let APV, armored personnel vehicle, be a sort of a hub, build a number of drones or things around that, and have their own communications bubble, and have this operate together with the eyes and ears. Drones give additional awareness. You can try to work with that. Technology can still help. Obviously, if there's an EMP, then it's still back to pen and paper, but then everybody's back to pen and paper. So yeah, you can build local autonomous systems and local autonomous mesh networks, maybe even based on 5G if you want, would totally be one solution. But again, that increases the complexity of all these vehicles. That APV will become a lot more expensive. All the AIs and everything in there will cost something, means that you will have less units, and that's also going to be a problem. You will have these high-value targets for an adversary.
And Ukrainian defense against Russian aggression is a fine example where, at least in the beginning, it seemed like we are not like typically we are preparing for the last war. We were all preparing for the next war, and then Second World War type of war hit us again. But by now we probably see that it actually is a war of the future in a way that now the modern technology flowing in shows how dominant it is on top of old solutions. But at the same time, I don't think that we get rid of this Second World War time technology. It's more like we need to have more capability on top of everything, but still old capabilities are there to stay, because you can go and kill a robot with an axe of like from Stone Age. So it's just world becomes more and more complex, and it once more emphasizes that we can handle that in cooperation between nations much more easily and resource efficiently than alone.
So Dan, you suggest that 5G and edge computing might be one of the kind of part of solution?
I have a strong dislike for buzzwords.
Yeah.
I could call it radio, but I can call it 5G as well, because I know some folks are looking at 5G for vehicles, vehicular networks. If it makes sense from a cost perspective, fair enough. The standard is good for local ad hoc networks in a way, might work well. Whether it's built for that, unsure. Whether it's resilient enough for that, also not sure. Sometimes if it's if it's easier to jam, then obviously you should pick something different. But again, radio I would defer to Mart on that.
We can send smoke signals or use lasers.
Well, but one side sends smoke signals, but the other one has a camera and runs AI on the visuals to decode the smoke signals.
Absolutely.
Yeah, well, this is how I explained my master's as well, how cyber works, that we still have the smoke signals and the couriers and the radios and the telephones. So, but again, this kind of the technological advantage changes the kill chain. So basically whoever has the advantage can project their kind of power faster. When I'm listening what you were just explaining, then in my mind, since I'm responsible for this area as well, so it's a kind of for certain type of radars looking for signatures, it's a Christmas tree. So basically, and as fast as I can put those drones and APCs and whatever kind of up there, I think with the same speed, I'm already listening some caliber type rocket flying towards that. So
electronic warfare is radio is also there for other people. So that's a nice shared spectrum which everyone can understand. And here's another point. We understand there's a tank. We understand there's an RPG, there's a javelin, a loitering munition, direct artillery strike, indirect artillery strike. We can people are pretty good at protecting the tank against these attacks because they have an understanding of how this attack comes. They've had for 100 years, approximately. However, for these electronic attacks and for cyber attacks, there is no mature understanding of how these attacks work or when they come. They come invisibly. They might come 2 weeks before the tank is even on the battlefield. The whole attack surface, the whole threat analysis has a lot more dimensions, and this is something that needs to develop significantly. And that part also has to look at these electromagnetic spectrum aspects, as in how much do you emit and how much you should control your emissions.
And the keywords here are, as already mentioned, is the distribution of systems. Instead of one big system, we have we can just hit one node and everything else will still work. And looking in space communication, of course, is 10,000 of low Earth orbit satellites is much harder to destroy as compared to a handful of old school satellites. But the second aspect here is also the cyber resilience concept, which actually says that we will hit, we will fall. The question is not about that. The question is about how quickly we can stand up. Yeah. And this Viasat attack was one nice example. If you have to restart manually every wind turbine in Germany is one thing, but it could be also one button solution to reinstall software, maybe. So anyway, technology development in cyber definitely is looking for new solutions, how to increase recovery, speed up recovery process.
The same process for installing a solution in all the wind turbines can also be used to shut them all off.
Well,
so really good intro in terms of coming back to the kind of. Do we have a question? Oh, yes, please. Can we have Mike here?
Yeah, great discussion here. How does cyber, as a growing vector of conflict in these hostilities and so forth, how is it changing the development of strategic doctrine with specific reference to what is deterrence today? How do military strategic thinkers now define deterrence?
Thank you. So, great question. So I think it's the same how we define cyber, which is basically every nation has their own definition of cyber. And some of them have many. We in Estonia have a cybersecurity law when we haven't defined cyber. For the military, we have defined cyber, what it is. But in terms of deterrence, in my mind, and we have a person who's much better to talk about this, so Laura, please feel free to jump in. But in my personal mind and having discussions on the strategic level with my colleagues, is deterrence is redundancy and basically your resilience. So this, that you know that whatever is taken out from your system, and this is something that we were discussing as well, that you still can kind of continue operations. So for example, Estonia had ID card crisis a few years ago. So one of our vendors actually applied keys on secret keys on our chips, which theoretically could be calculated, and we had to revoke like almost half of the active ID cards.
Less.
And we had mobile ID and smart ID, which basically saved the day. So the redundancy was built in the system. And in military, you have to have the same. So basically, and this gives you the kind of the resilience and the deterrence in kind of the cyber domain. All the other capabilities, it's really hard to put them in this context for me, but please.
Well, I would say that deterrence is overrated. So it's difficult. It's easier for people to be scared by atomic bomb than for not having water for a couple of days. So this it might be used as a way as ransomware is used today. So you just kind of say that you will kind of lack, your people will not be happy with you, the government. We take down some critical infrastructure there. That would mean that our side has declared our intention to use offensive cyber weapons, offensive side, which we are currently hesitant to do. So this one is one element there.
There's one part, although I would have to focus. We talk a little bit about the science fiction kind of weaponry here. Not much of that is on the field. If you talk to some infantry folks today, I don't think they care much about cybersecurity of their vehicles because they are pretty mechanical. The question is the things that are being built now. It's like that Murphy's Law in the book, where if construction engineers build buildings as software engineers make software, then the first woodpecker would destroy society, right? Just going, everything goes, right? So that's a sort of a concern that as we like these technologies of AI and machine learning, then engineering this into all these new systems, we create these new attack surfaces that are not yet fully understood. So I would say that right now it's a cyber-physical doctrine, but it might get more cyber. The cyber might get more capitals in 10 years' time, 20 years' time.
But the fact is that the work on doctrines is active. Our NATO CCDCOE is a custodian of NATO Allied Joint Doctrine for Cyber Operations. So it's ongoing work to look how NATO can cooperate on cybersphere. And like in every other business or domain, if we are strong, if we are working hard to prepare, then there is a chance that the cost of attacking us from the other side is too high. But as I said, deterrence overrated means if you stand against a crazy person or a person who doesn't share your values and doesn't care about her nation, but his personal goals, then it doesn't matter. The more blood, the better for that particular person. So the conflict will be ignited anyways.
In information security, we call that an irrational attacker.
Yeah. So, and obviously, I don't see any nations who are actually declaring what kind of offensive capabilities they have. So using it can't be deterrence, part of deterrence, because and how do you get the information about successful cyber attack? It's through an information operation. So basically, nobody knows that you've been successfully attacking something if you don't say it out loud. So basically, it's a kind of a messy area. I would agree with Mart here that it's overrated.
There's also one thing, you don't need to actually attack something, you just need to say that you did. That's something that we learned in internet voting. People didn't actually need to break it, they just had to say that they did, and news got around. So there's a clear thing there that sometimes just doing this is enough.
Yeah. Any questions from the audience? Armando?
So we're talking about the advance of technology, artificial intelligence, launching, satellites into space, ground station, downstream, encryption, quantum, all of those things. And I love your comment about the fact that there's a lot of things that really aren't there. I mean, the promise isn't there, like artificial intelligence, the famous Alan Turing comment of, if a computer can fool, I'll believe it when a computer can fool me into thinking it's a human, right?
Yeah.
That's when I know it's really, artificial intelligence. it's sad to constantly go here, but everybody in technology all over the world is going to. The lessons learned from Ukraine, while we saw that their ability to move satellites, via Starlink, it told us two things. One, there was only Starlink, right, as a viable, rapid deployment option to give them, the reconstitute capability. I mean, at least someone that was willing to do it, had the assets, did it initially for no money, right? So that's one thing: the resiliency, the redundancy of moving assets around when you lose a geospatial or satellite-based constellation, either to a kinetic attack or electromagnetic attack or directed weapon attack, all of those things that we're seeing the Chinese and the Russians probing on. But the other lesson is that as smart as all of that technology is, we're watching infrastructure attacks. We're watching kinetic infrastructure that are debilitating supply chains or debilitating the power grid, communications, and forcing the Ukrainians into bunkers, into less adroit capabilities to defend themselves from an electronic and information warfare perspective. What is the group's opinion about using cyber and space warfare or space intelligence to build more resilient critical infrastructure to be able to sustain the operations that rely? If you're in a bunker with no power and no internet, what good is a satellite? You know what I mean? So just curious in that realm. And second, as I've been working,
we don't have time for two questions. We have only 4 minutes.
With the Ukrainians, there's a rush to implement new technologies, right? But what I notice in the rush to save yourself because you're in a combat, right, where lives and critical infrastructure and society is at stake, I'm noticing, to I think almost your point, they're not looking at the cyber resilience of the platforms that they're looking. So if I give you the best technology because you see it and you need it now, this is literally a live example, I go, well, what about the infrastructure? If it's already compromised, if they can already see what you're going to see, you've already lost. And in a matter of crises, using cyber to make sure that we're resilient in a matter of crises so that we're not focused on the objective, but also the infrastructure that the cyber relies on. So two really infrastructure questions, one more kinetic and physical, and the other one more pure technology. Sorry, Mihkel, you told me to ask a question, so I did.
Yeah. So I'm going to let Dan.
I think the answer to the first question was yes. And the second question that I'm not sure, Mart will answer that one.
Well, I would answer that one very important part of the infrastructure is also humans. And Estonian answer is that let's have Cyber Defense League. Let's have many, many volunteers trained to be capable to step up and support IT systems if they fail, and good old human brain power is needed. So I think that is very important for all nations to keep in mind.
Jokes aside, and for the first question, yeah, I do have a solar battery-powered radio at home. So that takes AM and FM, might work. A 5G phone might not work. Yeah, there's a certain, you don't need to go back to absolute basics, but certain things, candles might be very helpful.
Yes. Bunker in Helsinki where the entire population can go.
Yeah. They have a lot of granite in Helsinki that really helps. Here we don't have that much good.
We have one question from back, and then I will decide how we will answer that.
Oh.
So the screens up in front are already kind of signaling us that we are in the danger zone.
Thank you. Quick question. In cyberspace, attribution is very difficult. It's got political, technical, and legal aspects. In space, is attribution going to be less difficult? And if so, will it be a deterrent to kinetic action in space?
Excellent question. Comes back to where we started from, situational awareness. So if we don't know what's happening there or resolution is too low, then they can tell us anything they want about what was the origin of the incident.
Done.
So one of Cybernetica's business has been marine surveillance, means that we just put buoys on the waterways and these collect radio information to try to identify ships. So just next satellite fleet is just going to look around for all the other satellites and try to monitor traffic.
Maybe Starlink is already capable to do that.
Yeah, they might. Wait, Elon doesn't tell us probably.
I think it's maybe easier as well because there are not many nations who can put stuff out there. So in that sense, in cyberspace, Russia is everybody's neighbor. China is everybody's neighbor. So it's a kind of a different story. But yeah, I think those who can actually... Oh, we got more time. Thank you. Magic. Yeah, magic. So yeah, but I'm not sure on the effect of the attribution because I think those nations who have the capabilities in space are already kind of talking to each other via back channels. So basically kind of coming out with that publicly, probably in this community right now does make change. Also, the cyber thing is similar, that in cyber, even though that we do attribution, it's a political decision first. So, and basically how much the politicians are willing to take a risk, then you can decide like what data is needed to kind of support this case. So, but again, I think a lot of this discussion is again in the back channels. So the actual effect, whether it's publicly announced or not, is not that relevant. So if we could point something towards North Korea and say like, did you do this attack? Then they would stand up, yes, so what? We have sanctioned them up so badly that there is nothing more to do with them. So basically, I think this is kind of publicly doesn't work.
Collaboration is key in chemical, biological, radioactive, nuclear. There's the CBRN coding system which collectively helps you identify what's going on and exchange information about it. There are efforts towards doing the same thing with cybersecurity between allies, for example. And as you very correctly said, in physical eyes on target, you don't have many eyes on target. If you had a satellite, good for you. If you didn't, sorry. In cybersecurity, some of the network, if you launch some of your attacks through public networks, some of your allies might have seen them. So they might give you early warnings, or they might be able to help you with attribution later. You might not be able to do all of that with your network if all of your inbound traffic is saturated, for example.
Well, the questions that you raised is actually very important. This attribution is a big challenge first place, because that tells us what the response would be. And there is just this finest example from cyberspace attack last 2 months ago, where a nation was attacked, and obvious answer was that these are Russians, because head of state just recently visited Kiev to show the support. And then a couple of hours or days later, some hacker group not associated with Russia kind of says in their webpage that no, we did it. So who is to blame? Who wants to? Do they want to take the fame? Who was actually behind it? Nobody really knows who actually was behind it. So it's all kind of statistical or political decision eventually.
Do we have one last question?
Yes. So the thought about what would happen if PNT was to drop. So there is been research that's being done even for HEO capabilities to possibly provide PNT. But just recently as well too, there have been a couple universities back in the States, both in Ohio and Texas, and they have been doing some research on LEO, particularly with Starlink. But of course, the response from Elon Musk is like, well, I'm not exactly going to provide that quite yet. But it has been proven, and one of the universities did prove to be able to use Starlink of up to, I believe, 8 meters. So it's the possibilities there for other alternatives. But one of the other questions I do have, though, and when it comes to the military using more of the commercial capabilities, at some point, do you think that the military then would have to consider their campaigning and planning and strategy in coordination with some of those commercial companies, because they'll eventually rely so heavily on some of them?
Absolutely. Done?
Yes. But there are obviously risks there, because again, governance. Private military is an interesting thing.
We already see that happening in the cyber domain with Ukraine. So a lot of information Microsoft is sharing and others are sharing. So
But if you give me 10 seconds for the last statement, 10
7.
seconds, 7 seconds. On top of all of that, it's about young specialists coming to the field. So it's all about human resource eventually. So the first thing to invest is education on cyber technologies and space technologies.
So thank you, Dan, Mart, for the great panel. Thank you for the great questions and for the extra minutes. And we stop right
On
now.
time, yes.